you will be learning. I'm Dr. Gayan. I'm a senior lecturer at Sri Lanka. I earlier worked at the UNESCO, but now I work at the community. For this lecture, I hope it will be useful for you to see different areas. It will serve as a foundation for many of the future classes you will be learning. And also, by the way, I forgot to lecture. And it will also serve you in life as well, day life as well. Okay. And by the way, audio is not clear. Give me a second to see if I can find some settings. Is it okay now? Is it better or worse? Then audio එක කොහොමද? තිබ්බට හොඳ? Okay, I'll keep the microphone close to me as much as possible. So this probability and statistic course will give you a lot of knowledge related to subject matter as well as everyday terms as well. So I know you like stories. So we will start this course with the story. Although I call it a story, it's a real one, true story. Okay. By the way, I like this to be a little bit more interactive. So please be free to ask questions, or if there are anything that you don't understand, you can ask me, and you can unmute and ask me if you want. That's perfectly okay. Otherwise, I feel like I'm just speaking to a wall. If you if you are a little bit shy, then you can put it into the chat as well. Right. You can see the PowerPoint, right? How you had heard of this particular mathematician or Abraham Wald? Anyone? Abraham Wald කියන mathematician ගැන mathematician කිව්වට statistician කෙනෙක් දෙකම ඉතින් ටිකක් related, right? Mathematician is that kind of go very close to each other. Those who have heard about this person, can you please raise your hand? මෙයා ගැන අහපු කවුරු හරි ඉන්නවනම් අත උස්සන්න බලන්න. කවුරුවත් නැහැ. Okay. How many of you have heard of World War II, WW2, Second World War? දෙවන ලෝක යුද්ධය ගැන අහපු කවුරුත් ඉන්නවනම් අත උස්සන්න බලන්න. 1, 2, 3, 4, 5. From group of 65, only 5. Okay, we are getting more. Good. At least half of you had heard about World War II? Right. Now, World War II was a very interesting period because that was the first time airplane was used as a military equipment. Early, it was kind of thought of like a toy, right? You know, when Wilbur Wright and Orville Wright made their first flight, many did not think of it beyond as a hobby or a toy. But in Second World War, things changed. And fighter planes become a major part in deciding the output of the war. But this is quite recent from the development of the airplane, right? So the airplanes were not that good. They were very prone to crash, failures, and all these problems because they were just learning how to fly. plane was developed only a few decades earlier. There were no major advancements. So it was just a kind of like a trial. So here's the story. So even although allies were using planes to the Axis route, however, the other side was also shooting planes. And remember, they were not jets and they couldn't fly very high. So you can shoot them down with the anti-aircraft. So some planes were damaged and crashed, some returned, some were partially damaged. So people wanted to build a better airplane. Or let's say they wanted to use the airplane much resilient way. So what happened is when airplane get damaged, when someone gets shot, it damages the plane. But you can reduce the damage on the plane by putting a thicker extra metal plate. Right? For example, you can put extra metal sheet on the wings, so it will be more robust. So the shots will not penetrate through it. So they wanted to know how they can improve the life of these fighter planes by putting the extra aluminum sheets. Now you can't cover the full plane with the screw. If you have to cover everything by metal sheets, then it will be too heavy. It may not even fly. Even if it can fly, it will not be easy to navigate and the range will be less. So you had to decide where to put the extra protective sheets, right? So that was the problem faced by these military people. They are able to put certain extra weight to the plane, so that weight can be extra metal sheet, but they wanted to know what is the best place to put this extra guard, extra metal sheet, so the planes can survive more. Everyone following up to this point? මොකද්ද මේ දැන් වෙන්නේ යන්නේ කියලා මේ දෙවෙනි ලෝක යුද්ධ කාලෙදී. Not sure. If you got the idea, raise your hand. Good. Right. Now here in the second slide, I am going to put you through some numbers. Now, these are not real numbers. I can't remember the actual numbers. If you want, you can, I think in the Wikipedia, it might be there. I just numbers. So what are these numbers mean? So what happened was now this force wanted to find the best place to put the sheets. So what they have done is they look at the planes that have returned and counted how many bullet holes in each place, right? Let's say per square feet or per square inch or something like that. So when they counted, this is the result they found. They found that engines usually get shot about 10 bullets per square feet. However, things like tail wings very rarely get hit. Let's say about 3 bullets per square feet. So this is just average, okay? They have a whole fleet of airplanes and they have taken the average value. Right, that you can see engine, main wings, tail wings, fuselage, blades like that. I can see there are different proportions, maybe because some angles or the way they are getting attacked, they are different, right? So the question is, now let's say you are the military advisor. You can put a guard or extra metal sheet in only one of these 5 components. You have 5 different places, engine, main wing, like that. You can put an extra protection in only one of these components. Which one are you going to put? Are you going to put the extra metal sheet in engine or wings, tail wing, fuselage, or the rotor? Put the answer in the chat. I want to know what you are thinking. Now, your overall objective is to make sure the plane is safe. Or let's say safer. You can't say safe. It's better suited for findings. Okay. Fuselage, fuselage, tail wings, fuselage, fuselage. Okay. People who say fuselage, we have different symbols, right? Let's say that's the reaction button. Okay, we have main wings as well. People who say that we can see two main categories of answers. Some say fuselage, some say tail wings, right? People who say fuselage, you can put a thumbs up. People who say tail wings, you can put, I don't know, let's say raise your hand kind of symbol. Okay, we can see two main groups competing with each other. Good, good. So at the beginning, the Air Force thought as same as the majority of you, majority of my students right now thinking. They look at the graph and thought, oh my God, fuselage is getting shot so many times, right? It's the largest, it has the highest bullet holes per square foot rate. That means the place that most of the bullets are getting shot. So better to protect it. So the Air Force wanted to put the extra metal sheet on the fuselage. But before they could implement it, this statistician, Abraham Wald, happened to randomly stumble upon this research group, or this military group, let's say. And he said, you are all wrong. You should actually put it in the tail wings. The people were confused because tail wing seems to be the one that has the amount of bullet holes. Why do you want to protect it? Then Walt came with a nice reply. He said, now you are counting these values, or you are taking these statistical numbers from the planes in your hangar. That means planes had gone to the war and returned, and only from these planes that you are taking the numbers. So what actually happens is, let's say the tail wing is the most critical component. Or let's say there's some part of the plane is very critical. Even if you get hit by a one bullet, the plane will crash. Then what's going to happen? You send these planes to the war, to the enemy borderline, and some of these planes get shot in that critical area and they shot down and crash into the enemy border. They don't return. They don't return. So what you are seeing here are the planes that have survived. So actually, even if you have an average of 16 bullet holes in the fuselage, you are able to come back and land safely on your airport. But you can't find a plane with even 10 bullet holes in the tail wing because they all crashed and got damaged. Right? So the Walt asked, okay, it should have some uniform distribution. So there are some missing bullet holes in the tail wings. So what happened to that? So what actually happened was when you get shot more than 3 or 4 bullet holes in the tail wings, they never returned. They were in the German side. So if they never return, when you look at the statistics, they are not there. Right? So this Walt, this particular mathematician, Abraham Wald, convinced the place to put the extra protection should be the tail wings, not the fuselage. Because in the fuselage, even if you get so many bullet holes, the plane managed to return. That's why you see planes with so many holes still in the airport. That's why you are able to take the statistics of those planes. Right? Do you understand the problem now? Do you got the idea? තේරුණාද කිව්ව කතාව? මොකක්ද එතන වෙලා තියෙන්නේ කියලා? Right? So now, the reason why I wanted to tell you this story is just having the knowledge about science, maths, or stats for that matter is not going to help you if you don't use the common sense and a bit of logic. But that doesn't mean stat or maths is useless, because you need to have it to have the foundation. Without this table, you can't have any idea. But just because you have the table, that doesn't mean your conclusions will be correct unless you think correctly. Reason is, in most recent days, last few years, if you look at things like news or any other things, you can see statistic is twisted to give very wrong or different impressions. Now in maths, it's a little bit hard. In maths, either something is true or false. You can't twist it. Either you prove something or you don't prove it. Stat is not like that. You can have the same table and you can interpret in different ways. So this is not just about doing some calculation. This is about a way of thinking. So while we are going through this lecture, I will show you some of the real examples that we saw in recent years in news and everything, where the true actual values or the actual conclusion is completely distorted. Sometimes completely opposite direction, right? You should be able to spot these things in everyday life as well, right? That's the difference between someone just memorizing equation and a university student who is able to analyze and actually see the truth, right? So when we go through it, we'll find these examples. In fact, I have a separate PowerPoint presentation showing these kind of tips and tricks you can do, because it's not only the news, even in academic, even in research papers, sometimes knowingly or unknowingly, people come to wrong conclusions. Yeah? Right. So that's a small story to wake you up. So let's go to our main presentation. So we have, this is a small summary of the things that we are covering in the first part of this lecture. There are several different parts. You have stat part, you have the probability part, like that. So in the stat part, we will be mainly looking at what is statistics, some introduction. And it breaks into different categories like descriptive and inferential statistics. What are the differences? Why we need them, things like that. And we will also look at some of the terms in statistics. Statisticians really like to coin new terms. For everything, they put a new word, right? So we look at some of the key terms and graphs and descriptive statistics and things like that. We will look as we go through the lecture. Okay, here's another interactive. I need you to tell whether you agree with this one or whether you don't agree with this one. Earth orbit around the sun. Do you agree with this? Yes or no? Earth goes around the sun. Now, don't think in very high detail like space-time curvature and anything like that. Let's say you are an average person, then what are you going to say? I hope there are no flat earthers in this course. I don't know. Maybe Okay, first one, everyone agrees. Income in Sri Lanka is higher than USA. Yes or no? No, definitely no. Never. Rose is beautiful than orchid. Rose is beautiful than orchid. Yes, no, depend. For some people, probably okay. Okay, good, good. Last three. Okay, I have put the all three bullets. Come, they all appear at the same time. Heavy metal causes kidney damages. Yes, no. Okay, last one. COVID vaccine increases disease rate. I don't know, no idea, do not know. Good. So what I wanted to show you is some of the statements everyone agrees. Very clear. The orbits around the sun, that's a agreed fact. Almost everyone agrees it, and you can prove it and things like that. But there are some statements that are depend on the person, right? For example, whether the rose is beautiful than the orchid. Well, it depends on the person. For some people, rose may be beautiful. For some people, orchid may be beautiful. We don't know. Because things like beauty, you can't put a number. You can't put a number. You can't scientifically put a number or share something and say, this is the beauty index or something like that. It's very hard. So we can clearly see there are two different distinctions. One category we can clearly mathematically or scientifically prove whether it's true or false. And some of the facts are subjective. Depends on the person. But the problem is certain statements, although they need to be objective, we put them as subjective. Now, the last point I actually put very recently, because in the in the new year, relations come and visit other people, right? So one of the relatives of mine came and said, that we talk about all the nonsenses and gossips. He said, COVID vaccine had caused heart diseases, and the proof was one of a person known to him got the vaccine, and after 2 weeks he passed away because of this particular disease. Now, what do you think about that statement? Does it prove something or does it prove nothing? Does it say that it actually causes it, or does it say it doesn't cause it? What can you say? We don't know, right? We don't have enough evidence to show. Maybe it is the actual cause, or maybe it is just a random coincidence. We don't know. Maybe the vaccine has nothing to do with it, or maybe it has to do something with it. We don't know. But that kind of problems or questions are important for us, right? In this case, whether to know that vaccine is safe, right? So then you have to find a way to either prove something or disprove something, or say with this amount of confidence, this is the case. Maybe not a mathematical proof, but you can say, okay, from this amount of people, we can see there's a significant change of the people who got the vaccine, or there's no significant change, right? So that is the place where the statistics comes in. It's kind of like a borderline. It's not like a exact mathematical proof, but it's not completely subjective. That means it's not completely depend on the person. You can give him some information. Okay, based on these facts, this is the most likely thing to happen. Can you prove it? No. So there's a rare chance. It might actually happen because of the randomness. We don't know, but we can come to some fair conclusion based on that. Right? So this is where the stats and probability actually comes into everyday life. Right? So here's a formal kind of definition of statistics. Statistics is the discipline that concerns the collection, organization, analysis, interpretation, and the presentation of data. Collection means you are gathering whatever the information. Maybe you want to know whether doing the past papers will increase the exam marks. So you need to collect some information. What happened in the past years? How many students have done the past papers and what are their marks? How many students did not do the past papers and what is the grade they have these people have got? Right? Then you need to organize it. Maybe you have given them some survey forms or have the viva or verbally ask them. Then you need to organize. Okay, number of past papers, the exam marks they have got, and things like that. Organizing, analyzing. You need to go through the data and see whether there's a pattern, there's a trend. Is there a relationship? Right? That's the analyzing. Interpretation. So interpretation is the place where most people get wrong conclusions. Okay. The same data can be interpreted in different ways. So in the interpretation, you look at these trends and come to conclusion, okay, people who did more past papers had got more marks. But you have to be careful. It might be the other way around as well. Maybe the people are more intelligent, so they are able to get more marks and they are able to also do the past papers. So in that case, it is not a cause and effect. We don't know. So you have to think very carefully about the interpretation and presentation of data. So once you come to an idea or a conclusion, you have to tell it to others in a way they can understand it and they can also see how you come to that conclusion. So they themselves can understand the result. So maybe put a graph or maybe put some numbers, right? You have to present your findings. So that is what the statistic is about: collecting, organizing, analyzing, interpreting, and presenting data. We will not go into deep depth of all these categories, but in breadth, we will cover all of them. So where is statistic is used? It is used in many scientific, industrial, and social problem solving. In short, it is used in almost everywhere, right? Almost everywhere. Right. Now that is the broad definition of the statistic. Is it clear for everyone? එතනට මේකන්ට එක තේරුණාද මොකද්ද ස්ටැටිස්ටික් කියන්නේ ඇයි ඒක අපිට වැදගත් වෙන්නේ මොකද්ද ප්‍රයෝජනේ good very good now remember stat is just a part of this course we have the probability one I did not touch upon that we have a separate presentation for the probability this is only for the stat so the stat can be classified into two main categories groups descriptive statistics and inferential statistics. Descriptive statistic and inferential statistic. What is descriptive statistic? Descriptive comes from the word describe. Describe means explain, show, right? Describe. So these are basically numbers. You just give some numbers. For example, you can calculate the GDP of several different countries. Maybe put it in the table or a graph and show it. Okay, this is the average income in the US. This is the average income in Sri Lanka. This is the average income in Australia. This is the average income in New Zealand. So you put some numbers. Just numbers, that's all. Or maybe you can calculate average marks for different subjects. For statistics, this is the average mark got by the students. For modeling, computational modeling, this is the average mark. For the basic mathematics, this is the average mark. You put some numbers. You don't come to any conclusion. You just put numbers. It's up to the viewer or the person who's reading your text or the person who's listening to your presentation to come to whatever conclusion. So descriptive statistic is mainly for either as an intermediate step or for a technical things. Like, let's say you want to build something, and to build it, you need, let's say, some metal sheets. You want to calculate the thickness of this sheet, right? You don't need to come to any conclusion. You just know to know the thickness of this sheet. Then you can measure it at several places and get the average. Just a number. You can say, okay, this is a 2 millimeter thick sheet. How did you get it? By getting several samples. Right? So that kind of thing. Just describing, putting some numbers. That is called the descriptive statistic. So descriptive statistic again can be, there are different categories. So in this course, we will be looking at summary statistics, graphs, and tables, right? Those are some of the ways you can put the description or the details and present it. Inferential statistics is, on the other hand, ask a question and gives a conclusion, right? It's more or less like a statement. Like, is the medicine A better than medicine B? So you don't just stop at the numbers. You have to come to a statement. Okay, based on this result, A is better than B. Now, in the earlier case, we just measure the thickness of the sheet. There were no conclusion. We just put the number. Maybe you are doing some calculation. What will be the average weight of this, whatever the thing you are building? Then you calculate the average thickness and calculate the weight. That's all, no conclusion. But let's say you have two different manufacturers. Then maybe you can compare the two sheets. Then your question might be, is the manufacturer A has thicker sheets than manufacturer B? Like that. If you have some kind of conclusion or a result or a statement that need to be validated or checked based on stat, that is called inferential statistics. Again, under inferential statistics, we will be discussing about hypothesis testing, confidence intervals, and regression analysis. So those are the two main categories, descriptive and inferential statistics. And in these examples, you can see most of these statements that need stat are actually inferential ones. For example, COVID vaccine increased the heart disease rate. So that is a statement. So we have to infer whether this is true or false. Or the organic fertilizer reduced the paddy production. Again, a statement. We have to check it to the stat whether it is true or not. That will be basically going to the hypothesis testing, right? We will be covering hypothesis testing later. We will first start with the first one, the smallest one. Summary statistic, this one. We add stat, under the descriptive stat, under it, summary statistics. So under the summary statistic, you have again 3 main types. You have the measurements of central tendency, measurements of dispersion, and the shape. Central tendency means you want to have a single value and you want to get something like, how do you call it? You can't say the average, it's like one value to represent all the data. Right? For example, someone will ask, okay, what is the height of a Sri Lankan? Now you can't start measuring everyone in Sri Lanka, and even if you do measure, you will have a collection of values. Let's say for some medical experiment, you want to know the height of a Sri Lankan. Then you have to find a single number to represent it. Right? So if you want to find a single number represent the center point of the data set, that is called the measurement of central tendency. Dispersion means how spread the values are, how far away values from each other. Are they very closely to each other? All the values are very close to each other, or they are very far away. Values are very different from each other. So how differ the values from each other? That is where the dispersion comes in. Shape means sometimes you have low values at high frequencies, high values at low frequencies, or things like normal distribution, things like that. That is where the shape comes in. So let's look at our first measure of central tendency. That is okay, we have 3 different ones. I will look at the mean, or sometimes known as the average. So average provides a single value to represent the observation. You already know how to calculate the average, right? What you do is you basically add all the values you have. I hope you are familiar with these symbols. This capital sigma sign, what does it mean? What does this sigma sign mean? Maybe you have heard it in mathematics or used it. Sigma sign. What is the meaning of this sigma sign? Summation. That means you need to add. What do you need to add? These xi's. So I goes from 1 to n. So that means x1 plus x2 plus x3 plus x4, like that up to xn. So this is the starting value. This is the ending value. So for each of these I value, you have to find x1, x2, x3 like that and add them together. That's what this sign means. And once you add them together, you need to divide by the n. Now, I made a small mistake. I should have put the details of all the variables or the parameters after the equation, but I had not put it. So I will verbally explain it. So this xi means the samples. By the way, I did not explain you to the sample and the population, right? So give me a second. I think I have put the slide in the wrong place. Let's say someone came and asked, okay, how many students are in our class today? We have 102. Okay, we have a lot. Someone asked, what is the average height of the students who are following this particular course? Let's say probability course. Right? So you want to know the height of the students who are following this course. So this number of students who are following the course, that is called the population. So that is the total number of people or things or items we are interested in. In this case, the total number of students in this course. That is called the population. In earlier example, I mentioned the height of a Sri Lankan. Then all the Sri Lankan men and women will be the population that we are interested in. Right? Now, obviously, you can't measure the height of all the Sri Lankan. In the class, you might be able to, because you have only 105, you can take 1 or 2 hours, measure all the students and do it. Right? In that case, the population and sample and everything is okay because you are able to measure everyone. You want to measure the height of all the students in the class and you are able to do it. Good. Perfect. No problem. But let's say you are interested in the height of the older Sri Lankans. Then obviously you can't measure height of all the Sri Lankans. There are so many people there. It will be a waste of time and the money and you will not be able to do it. Then we select a part from the population. We call it as a sample. By the way, I think you need to put the attendance. So let me share a Google form for you. So I will put the Google form in the chat. So you can fill it and send it while you are listening to the lecture. Okay, now it's in the chat. So in the case of the height of the Sri Lankan, you can't measure everyone. So you select a subset. Subset means a part from the population. Since you can't meet all these millions of people, you try to decide, okay, I will take 100 people, maybe 200, maybe 1,000, and measure them, measure the height of those people. So that is called a sample. So when you're selecting a sample, you try to make it represent the actual population. Right? Because you want to make it look like a mini population, right? A cross section of the actual people you are interested in. The only reason you are taking sample is you can't measure the statistics of the full population. Right? If you can, you should go ahead and do it. If you can't, because the number of items are very large, then you take a sample. But when you're taking a sample, you should make sure it is a fair sample. For example, if you want to take the average height of the people in Sri Lanka, and you took the sample as the grade 5 students, it's not a fair presentation because that's a very specific set, not a random set. That only represents a particular group of people. So your value will be less than the actual value should be. Right? So that's the difference between the population and the sample. And now you should understand why we need sample. Right? So we have something called sample fraction. That's the ratio between population to sample size. Larger the sample, the better it is. But of course, you will have some practical limitations. You have to be careful. So that's the difference between population and sample. Is it clear? Take a Right. Now, let's say you want to calculate the average. So if you want to calculate the average, whether it is sample or population, you have only one formula. That is, you have to take the arithmetic mean. Arithmetic means you add all the measurements and divide it by the number of items. So if you have 10 students, you measure the height of all the 10 students and then divide it by 10. Then you get the average. So n is the number of items. So this can be sample or the population. Capital N usually denotes a population, right? So this equation basically says population. Even for the sample, that's okay. So you add them and divide by the number. And the average is represented using X bar. X bar, that is the average. Right. Now I want you to do a small exercise. Here's a table. So you have measured the diameter at different places. We want to get the average diameter. The average and mean both have the same meaning. Average diameter of this cable. Can you quickly do it? If you want, you can use the Excel or calculator, or if you want, you can add them by number, by hand, no problem. Put the answer in the chat. What is the average diameter of this particular wire? And those who joined recently, I have put attendance sheet link into the chat. So just put those who have not responded, please put it, please fill the form because I can only see 66. So the remaining for around 40 people, please fill that form. So we can put the attendance. Very good. So that's 1.55. So I mentioned that for this calculation, we assume the measurements are ideal, so there are no errors. Later on, we will discuss about error calculation, because when you are doing actual measurements, you can't measure a value perfectly. There will always be an error because your measurement equipment is not perfect. It can only measure a value accurate up to a certain point. But when doing it, you will have to think about that as well. But for this one, we don't need it. We just put it like this. Right. So then we have another measurement called the median. So median means you arrange your sample data or your data in ascending or descending order. That means in the increasing way or the decreasing value. And you select the value in the middle. If you have two values in the middle, for example, if it's an even number of samples, you will have two values at the center. Then you take the average of those two values. But if it's an odd number, you will have only a single reading, single number, then that will be your median. For example, in this case, you have 1, 2, 2, 5, 6. So they are already in the ascending order. So the value in the middle, you can see this is right in the center of this particular number series. So this will be the median. Most of the time we use average in our calculations, but there will be times where median is more useful. Especially if you have an outlier, then median will be much more reliable than an average. So what do we mean by that? Here's an example. You may have done this when you're at A levels. when you're calculating the Stokes law. You drop a ball through a viscous medium and then you try to calculate the force. Now, one of the readings need for this particular calculation is the time. How long does it take for this ball to fall from top to bottom over a given distance? So now a student is doing this experiment, and any experiment, you know that you have to repeat it several times to verify. In scientific methods, you don't do it once and come to a conclusion, you repeat it and see whether you can get the same result. So this student has repeated this experiment and had collected following values. Now I want you to calculate the mean and the median for this one, and then also answer the second question. Which one do you think is the better representation for the value? For example, he want to use a single value for his calculation, maybe to calculate the viscosity of this medium or something like that. So you need to have a single value. So there are two different ways to calculate. You can calculate the mean or the median. So calculate both of these values. And then looking at the data and using your common sense, tell me which one you prefer. Are you going to prefer mean or the median, right? Okay, quickly go ahead and do it. Very good. Most of you have calculated it. You have mean around 13.3 seconds and the median about 11.2 seconds or 11. Yeah. So based on these numbers, which one do you think is the better value to be used in the equation? Is it the mean or the median? And why is the reason? Let's say now we want to calculate the viscosity. For that, he need to have the single value for the time to plug into the equation. Which one will you use if you are the students? Are you going to use the mean or the median? Okay, most of you are saying mean. Okay, so this is where I said you have to be careful about what you are doing. For example, if you look at this value, you can see, now remember, this is the same experiment repeated several times, right? So that means we expect to have some similar values. Not identical because we have human errors and all these things, but at least values very close to each other. So you can see this one is around 10.9, 11.2, 12 point something, 21 point something, and again 10 point. So we can see most of the values are very close to 11 or 10 or something. But this one has a 21, we don't know what happened. If you look at the mean, you will see it's 13 point something. No, none of these values are close to that one. Median is 11.2, which seems to be a reasonable one. So what I'm saying is, now don't get me wrong, when you are doing the experiment and doing the calculations, we usually use the mean or the average. That's correct. But we are doing it under one assumption. Assumption is there are no outliers. What are outliers? Outliers are values that are very extreme cases. For example, what do you think about this value? All the values are very close to 10. This one has somehow gotten to 20. So most likely scenario is student had made a mistake. Maybe he forgot to reset the value. So this might be actually two readings in one. We don't know. But somehow this one doesn't seem to fit here. So in a case like this, you can see most of them are very close to each other, seem to agree with each other, but there's one outlier. Outlier means extremely high or low value. Since you are taking the average, this single outlier can pull all the values up and your average will be somewhere here. Not in this line, but a little bit up here. So this point here actually doesn't represent the real scenario, right? Probably your value should be somewhere along this line, not up here. The reason it came up here was this outlier. So if you are doing an experiment, we usually look out for the outliers and come to find why there are outliers. That's again important. Maybe that's not an outlier. Maybe that's something that happens time to time, right? Now, don't get me wrong. Sometimes, so I mentioned that sometimes people can manipulate the data to get whatever the values they want. So this is again something similar because it's up to you to decide which ones are outliers, which one are extreme cases or mistakes and neglect them. But you have to be unbiased and fair in the judgment. Right? Because sometimes, knowingly or unconsciously, we remove some data points because they don't match our idea or our result. or our hypothesis. But in reality, they are not outliers. They are actual data set. If you put it, what we earlier thought was correct may be wrong. So that's the wrong way of doing it. But there can be real outliers as well. Maybe there's a mistake in the experiment. Maybe there was a problem with the take in the reading. Or maybe your sample had some completely different item somewhere, mistakenly put in there. So that kind of thing you can remove, saying this is an outlier. This is a very extreme case. It's not something that we usually find, so we'll remove it and take the average. If you do that, that's fine. Otherwise, these outliers will tend to change the mean. However, outliers will not change the median. They can usually tolerate the extreme values. Right? They can usually tolerate extremely high or low values because they will be anyway removed. You are only looking at the middle. Right? Now, I am not saying median is better than mean or the mean is better than median. It's not like that. It's like apples and oranges. You have your different cases, different places where you need to use them. But if you are using the average or the mean, be careful about the outliers. If you have decided to use the median, for your case, let's say you need to use the median, then outliers rarely have any effect. Right? So that's the point I want to tell you. Depending on the case, you might need to use mean or median. They all have their advantages and disadvantages. So keep this in mind. And if you're using the mean, be careful about the outliers and you may need to remove them. And when you are removing them, make sure it's justifiable. It's justifiable. Right? Let's say, for example, you want to compare two classes in the school, class A and class B. So class A teacher want to make sure that he's the one winning. So he says, okay, there are 5 students who have scored 0. These are outliers, so I remove them and keep only the remaining ones. Or maybe I will remove the 10 students who have got the least mark. In that case, that's not a justifiable scenario. Arbitrarily removing the 10 students. Then of course, then your average will go up. Average will go up. But that's not a good way to do it. Right? So that's why I mentioned you have to justify why you are removing it and show that it's actually an outlier. Right. Then we come to the last one of the center, measurements of center tendency, that is called the mode. Mode means when you have a lot of data, which one repeats most of the time? Or which one occurs most of the time? Right? Let's say you want to know what is the number of textbooks a grade, let's say 5 or grade 10 student carries to a school. So you get some bags from the students and count how many books they carry. And the number of books that's repeating most of the time, let's say 8 books repeat 10 times, then that will be the mode. Right? It will be the mode. So the mode can actually be used with categorical data. So that means if you are looking at something like average or mean, you have to use it with numerical data. That means numbers. You have to add them, subtract them, divide them, things like that. But there can be categorical data as well. For example, in a garden, you have different types of fruits. So in that case, mode will be the number of, let's say, different type of fruit trees. Then if you have a lot of mango trees, that will be the mode of that one. So you can use it with categorical data. That's a special scenario. Right. For this one, what is the mode? What is the mode of this one? There's a question. 12.4 isn't the median of in this equation. That's this one. Okay, mode is the one that you have repeatedly has most. Okay, 1, 2, 3, 4. Yeah, I think 42 is the correct one. 12.4. There's a question saying 12.4. Isn't it the median of in this question? So you have to put it in ascending and descending order and find the one in the middle. So you have 10. You have 2 10s. 1, 2. You have 1, 2, 3, 4, 5 numbers. So that means the third one will be the one in the middle. First one, second one, third one. This will be the middle. Then you have the fourth and the fifth. Right. Mode you have calculated now. So here's the summary. Mean, they find the average value in the data set. Median, you find the middle value in the data set. Then you order it in ascending or descending order. Mode finds the most frequently occurring value in the data set. I hope you understood these things. These are very simple ones. Probably you have covered in your A levels or O levels as well. Right. So with that, we cover this particular part. Measurements of central tendency. Now, when I give you a sample, you should be able to calculate the mean, median, mode. Okay. We'll now move to the next one. Measures of dispersion. That means how far away the data set is. Here's another example. Now, I told you earlier, central tendency, values of central tendency is for finding a single value to represent your data. However, that doesn't tell the full story. That doesn't tell the full story. Here's an example. Let's say, I earlier mentioned that we are building some machine or something, and for that we need stainless steel sheet or something like that. So someone has taken 4 measurements for this sheet at 2 different manufacturers. You have manufacturer A, when it measure 4 different places, this is the values he had got, and this is the values for the manufacturer B's sheet. Now, when you look at the average, both of them have 10.5 millimeters. Now, if you are to select a sheet, or if you want to select the good one, which one do you prefer? Sheet A or sheet B? Which one do you prefer and why? Let's say you are making some machine or something. So from which manufacturer are you selecting? 1, 2, 3, 4, 5, 6, 7, okay. Most of you are saying A. But why? Consistent, minor deviation, okay. Any other answers? Not far from the mean. Product quality is good. Okay, now that's a okay, whatever. We don't know the quality, we are just measuring the thickness. It has decimal number millimeter. Not sure what that means. Not large deviation. So if you look at these ones, you can see it's almost the same. Right? That means the thickness of this metal sheet is almost constant. not exactly constant. You can see there are some minor deviation about 0.1 millimeter, more or less at certain places, but most of the time, it is the same thickness throughout the sheet, at least in the places that this person has measured. But from the manufacturer, this one, you can see they are all over. Sometimes it's very thin, sometimes it's very thick, right? It's like someone had taken a hammer and slam it somewhere here and there. So some places are bent, some places are thick, some places are thin, right? So the average is the same, but you can see there's a difference in quality. This one is the almost the same, uniform. Well, not uniform exactly because you have some small diversion, but almost like that. Fixed thickness. This one is all over the place. So by looking at the data, we get that idea. There's a difference between A and B. But now we want to put some numbers into it, right? Statistic, we always try to put some numbers. So we want to know how consistent these values are, how close they are to each other. For example, these are very close to the average, almost 10.5, while these are very far away from each other. Some are very far away, some are quite low, like 8.5, while others are very high, like 12.5. So we can see there's a large dispersion in this one. So we need to have a way to measure this dispersion, how far away the data points are. So that's the next one that we are going to learn. So you can calculate the dispersion in, again, many different ways. The first one is called the range. Range means the difference between the largest and the smallest numbers. So what is the range for A and B? Calculate and quickly put it there. Range is one way of measuring the spread of the data values. Very good. Okay, here's a side question. Can you think of a everyday life scenario where we might use something like a range? It doesn't have to be numbers, but everyday life, sometimes even without numbers, we have some idea, okay, this is the range or things like that. Where do we use the range? Oh, I should have started from the beginning. We had learned about the average, right? In everyday life, where do we use the word average? Where do we use Where do we, sometimes knowingly or unknowingly we use these concepts. We may not call it as average, but that's what we do. At the end of the day, if you look at what we have done, we have used the average values to come to certain decisions. Can you think of some examples? Where do we use average? Well, here's an example. Okay, now, then I need you to come up with some more. Okay, let's say you have, let's say there are 1 or 2 different shops near your home, right? Maybe some retail shops, or maybe a Kiehl's or Cargill's or something. And every week you need to buy some goods from these shops, maybe vegetable stall, or maybe some everyday items. Then how do you decide which shop to go? Let's say there are 2 vegetable stalls or fish stalls. So in the vegetable stall, you buy about 5 or 6 different vegetable items every day. So there are 2 stalls. Assume both of them have same kind of quality. Now, quality, I don't know how to measure it here. So how do you decide which one is cheaper? Which shop is cheaper? So when you talk with someone, we will usually say, okay, in Sinhala we say, Samanning ara kade badu labal. Right? So when you say Samanning, so that basically says on average, the items in that shop A is cheaper than shop B. So if it comes to vegetables, maybe some items are a little bit higher than the other shop. Maybe onions are a little bit higher. But when you add them together, you will buy several items, right? Maybe 5 or 6 different vegetables and onions and everything. When you average them together, you find shop A is cheaper than shop B. Then you will go to shop A. But item wise, maybe some will be cheaper, some will be more expensive. Then knowingly or unknowingly, we use the concept average. Right? You don't compare one item at a time, but in average, you notice, okay, this is the cheaper shop. Right? And when it comes to range, here's another one that that comes to my mind because we are New Year season, right? So we usually take banana or plantain to your relatives, or they bring them to us as gifts, right? And when you look at them, you can see there are different amount of ripeness. Sometimes in the same set, you have a very ripe banana at one end and almost a green one at the other end. Sometimes you have everything ripe to the same level. So depending on your need, you can select which one you like. For example, if your family has only 1 or 2 people, getting a banana completely ripe or uniformly ripe will not be a good idea because most of the banana will then overripe at the same time. You have 10 bananas and all the 10 will be overripe at the same time. But if you have a range, one is green, one is yellow, by the time you finish maybe 1 or 2 banana and the following day, the rest will become ripe enough, and the following day it will become again, the green one will become ripe, right? So then you have a range. So at that time, we don't use numbers, but in our brain, in unconsciously, we look at the range. This banana has a wide range. One is almost ripe, other one is still green. And you might find another set that is uniformly, all of them are yellow, right? Like that, we use those words, range. Okay, now coming back to our scenario. So you have calculated the range, very good. Now I am going to introduce you to another concept called quartile. Now, earlier, range meant the smallest and the largest value, the difference between the smallest and the largest value. That is okay, but if you had an outlier, that means one or two extreme cases, range will not be a good representation of the dispersion, because that single value will quickly change the whole range, right? You got the idea, right? If you have an extreme value, your range will not mean much. This one extreme value can push the range beyond the considerable acceptable value. Therefore, we use something called quartile. That's another concept. What's a quartile? Quartile means we arrange our data set in ascending or descending order. Let's say this is our data set. And we already know three different things about this one. This will be the lowest value. This will be the highest value. Difference between this will be the range. And right in the middle, you will have the median. Right? Right at the 50% mark, you have the median. Those things we have covered. But we can add two extra readings, all the first quartile and the third quartile. First quartile will be at the 25% mark. So 1/4 of the way, it will be the first quartile. Right in the middle, at 50% way, you will have the second quartile or the median or the middle quartile. At 75% mark, you will have the third quartile. And here you have the highest mark. So another way we can put some numbers into dispersion is through the quartile. We can say, okay, this is the Q1 value, Q2 value, and the Q3 value. Right? So this is more robust to extreme values. Right. I don't think I need to give you some numbers to do it because it's self-explanatory. Just like calculate the median, but not in the middle, but 1/4 way from the lowest value and 1/4 way from the highest value. Right. Now we come to another very, very important topic, variation and the variance and the standard deviation. I hope you remember I mentioned there's something called a population and a sample. Population is the whole set of items that we are interested in. Sample is a subset of that population. And the reason we take a sample is we can't measure all the properties or the parameters of the population. When it comes to calculating the variance, there's a slight difference between them. By the way, I need to make a small change. This should be simple n. Right. So if you are calculating the population variance, that means you are calculating the variance of the population. You are interested in the variance of marks in your class. If you are using all the members in the class, you are using the population. Then to calculate the variance, you use this particular equation. But if you're using a sample, then you use this equation. Now the change is this one. If you're using the population, you are dividing it by the capital N. That means the number of samples in the population. But if you're using a sample, this is the simple N means number of items in the sample. So you need to subtract 1 to get the correct value. I will not go into theory part why this is so, but you can find it in the internet or Wikipedia. There's a reason why you need to have this -1. It's a correction factor, right? It's a correction factor to make it more accurate. get more accurate value, right? But other than that, the equation is the same. So what is the equation? Xi minus X bar squared. What does that mean? We know X bar means the mean or the average. So what we do is we basically look at each sample and measure how far it from the average. Is it very close to the average or is it far away? So to find that, we subtract it. We subtract it. However, when you subtract it, sometimes it will have a positive value. Sometimes we have a negative value. Now, if we just add them up, we will end up with a very small value or almost a zero, right? So to prevent getting a zero, we need to make sure all the negative values are positive. So the easiest way to do is to take the square. So when you have a negative number, it will be squared. It will become positive value. And if you have positive value, when you square, it will still be a positive value. So what you're doing is you are basically measuring the distance for each data point from the average. But you are disregarding whether it is positive or negative. You do it for all the samples and divided the number of samples. Sorry, divided by the number of items. So the same thing for the sample. You measure the difference, square it, add them, and then you divide it by the number of items. So this is the equation for variance. And another common thing that used for used in statistics is called the standard deviation. It's basically the square root of the variance. So here you might remember we have taken the square. We will bring it back by taking the square root. This is one way of calculating it. There's another way of calculating this. X squared bar minus X bar squared. So now remember, these two have two different meanings. This one means you take the average and then square it. Here it means you square it first and then take the average. Those are two different things, right? So we'll do some calculation and then you get an idea about this one. So this is a sample. So calculate the sample variance for both of these cases. And the sample deviation, standard deviation, okay? Quickly do it. By the how many of you are how many of you are using a scientific calculator? How many of you have a scientific calculator? Scientific calculator තියෙන කී දෙනෙක් ඉන්නවද? ඔය FX991 වගේ එකක්. 1 2 okay. Now, since you are at home at this moment, maybe you can use Excel to do the calculation as well. But when you are doing it at the university or maybe the exam, you may not have the computer, right? But you will be allowed to use a scientific calculator, something like a FX991, something like that. Now, make sure you go through the manual, because in those calculators, you can automatically calculate things like standard deviation, average, and everything. There are two different ways. Most calculators have a different modes, right? You have vectors mode, you have matrices mode, you have complex number mode, and another mode will be the statistic mode. So in that mode, you can enter the data and ask it to automatically calculate those values. Or you can use it as an equation. Now, these calculators, you can type your own equation and put the values into that equation. So it's a very easy process. Once you type the equation, you just enter a set of numbers and it will go through the equation automatically and give you the result. Right? So learn how to do that. That will save a lot of time. Right? Otherwise, if you are taking the average and doing it manually, even when I say manually, I don't mean that doing it by paper and pen. I mean, even with a calculator, it will take a lot of time. Right? So there's a difference between a normal calculator used by a cashier and a scientific calculator, right? At a shop, you just need to add numbers, maybe give a discount, and that's all. But you have a lot of extra buttons on your calculator, and the cost is also high. So make sure you know how to use those extra buttons. So that's the only way you can get the value that you paid extra, right? So then you should be able to do these calculations very easily. Right, so that's something extra. You are still calculating, it seems like. No answers so far. So quickly do it. Okay. Seems like people are getting different answers. So you have to, so I mentioned, we want to calculate the sample variance. We have to use this particular equation. So n in this case, the number of samples 1, 2, 3, 4, n will be 4. And average, I think we have already calculated in the previous scenario. The average of average is 10.5. It's already given 10.5. And here, for each of these values, you have to take the value from this table, subtract 10.5. Here it will be 0. Square it. And to it, you have to add the next one, 10.5 minus 10.5. Sorry, 10.4 minus 10.5 minus 0.1. Square it, add it to it. Do it for all the values, and then divide it by 3. And that should give you the sample variance. And then you can take the square root of that to get the standard deviation. Okay, you can get the square root of that to get the standard deviation. By the way, you can simplify this particular equation, expand it, and you can derive this one from this one. Not the standard deviation, not the sample variation. You have the same scenario. Only thing is, instead of having x, you can derive it from this one as well. Right. So once you know the equation, I think it will be very straightforward for you to do the calculation. You should be able to do the calculation in the exams as well. Now, for the last topic on dispersion, skewness. That means how the values are distributed. How the values are distributed. Sometimes you have something called symmetrical distribution. That means the values above the median and the below the median this are the same. That means mean, median, and mode, they are all same. You have symmetry like this. Sometimes you have a positive skew. Skew means you have this kind of a tail. You can see a long tail in the positive side. It's going like this. While the negative side, you have a very short one like this. In this kind of scenario, your mean will be the largest value. Why? Because of this tail, the mean is dragged into this side. We talked that when you have extreme values, mean can be affected by it. Here, when you have a tail, that means you have some extreme values to this side. So the mean will be affected and move towards that edge. Similarly, if you have a negative skew, mean will move toward that one. Median will also be a little bit affected by it. However, the mode is the majority, so mode will be the peak. So the value at the peak will be the mode. Median will be in the middle. So this kind of distribution is known as a positive skew. This is called a negative skew. This is called a symmetrical distribution. So if this were marks, and if this is the number of students, y-axis is the number of students, and if this is the number of, this is the marks of the students. Which one do you like to have? If I am to give the marks to your class based on these three distributions, which one do you like to have? Do you like to have a positively skew mark distribution, symmetrical one, or a negative one? Right, I know. Here you can see it's in the middle. So the fail guys and the pass guys are almost the same. If you say the pass mark is in the middle, they are almost the same. But here you can see lot of students have failed. You have majority here. Only few have passed. They have scored more, but number of students is very low. Here what have happened is it have moved into this direction. So the majority of students have scored a lot. They have got more marks. So students will like to have a distribution like this. Teacher will usually like to have a distribution like this. But if you don't study, you might end up with a distribution like this. Right? Because there's a saying, if there's an exam where all the students are failed, there's a problem with the exam. And if there's an exam where all the students are passing, again, it might be a problem with the exam. I don't know. So we will try to move to this side. You can try to move to this side. Don't end up in this side. Okay. Here's the summary. So the summary statistics provide several numbers to describe the observations. Okay. Some of these numbers will describe the center of the distribution, while others will describe the range. Not the range. Range is a word in here. How dispersed, how far away the data points is. So far we have learned about the mean, median, mode, range, interquartile range, that means Q1 and Q3, variance and standard deviation, and the skewness. Except for the skewness, others I have given you the equation and the ways of calculating. So when a data set is given, you should be able to calculate them. And if a distribution is shown, you should be able to understand whether there's a skewness in this one, it's positive or negative, or whether where's the mean, where's the mode, and things like that. Right? We have about 10 more minutes, and I will have to use that 10 minutes to go to another PowerPoint, which might be interesting for you. By the way, we had lost 2 days because I couldn't conduct the lectures because I was not well. So I think it's better if we can do some extra classes to cover that part. So that way, we don't have to rush and you can learn quite freely. So I was thinking when maybe we can do it in Saturday evening or somewhere like that. How about you? I know some of you are doing jobs. So what will be a good time to do some extra classes? Will you be available on Saturdays? Can I do something like 7 to 9? I don't know, 7 to 9, 6 to 8. You can suggest. What will be a good time? Now, I was told you some of you are doing jobs, so it will be better to have a Saturday evening. Only problem is the weather in these days is not very good. So if there's thunder and lightning, I'm not sure whether we can continue, but if it's not, we can definitely continue. 8 to 9 is just 1 hour. We need at least 2 hours. Extra class on that time. Okay. When is that extra class? Is it from 7 to 9? 7 to 9. Usually these students have their own WhatsApp group or something like that. Do you have something like that between you? Okay, then probably you can discuss it among yourself, and maybe one person can inform me, 1 or 2% can inform me what is your decision. So that will save time. Because I don't know how many of you are having classes, how many of you are doing jobs, what will be the free time, right? So discuss it among yourself. And I think we have about 6, 7 or 8 extra lectures. So within that time, we can put some extra classes. Ah, yes, presentation is already there. Only thing is I only uploaded it yesterday. So the presentation should be available for you to watch and download. This one is not there. This one I will upload once I finish this one. The one I did earlier, it's already there. Right. So you can discuss among yourselves about what to do with your free time, or what to do with on the Saturday free time. At 1 o'clock, do you have another lecture or is it your lunch time? 1 o'clock, is it your lunch or lunch? Right. You have the other one at 1:30. Okay. Then I have to do it fast. Let me see which one can be a small one. Or maybe we'll cover it next day because it's 12, almost 1 o'clock. I'm afraid this will take about 10 or 20 minutes to explain about this one. So next day we will then cover about statistical pitfalls as well. So this is a side one. I will not ask about this content in the exam, but these are things that are good to know. I mentioned earlier that sometimes people use statistics to trick others. So I'm just going to explain some of these methods. Not for you to trick others, but for you to know when you are being tricked, right? So that's the idea. So that's it for today then. So I hope you have enjoyed today's
Recording
lecture.
stopped.
Any questions you want to ask? We have about 2 minutes. So if there are any questions, any content that's not familiar for you, or anything that you want to ask for extra details, this will be a time for you. No questions? Okay. Then we will wind up for today and we shall meet on next Sunday. Will the record be uploaded to the exam? Sorry, LMS. Yes, we will upload it to the LMS. It's like in the previous day.